Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a is which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x. So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation. Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So I want to find the value of x here. And for my solution, start by writing this as x to the power of x is equal to x to the power of 2. And now I'm going to divide both sides by x to the power of 2. So then these two cancel out, and I get x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, and make sure to remember this property because this is a very important property of exponents. But if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2 is equal to x to the power of x minus 2, and this is equal to 1. Now, from here, what I can do is take the ln, or natural log, on both sides. So I get ln x to the power of x minus 2 is equal to ln of 1. And the reason I did this is because we have x as a normal term as well as an exponent. So we want to get this exponent down to be a regular term. And the way I can do that is by taking the ln on both sides. And if I have something in the form ln a to the power of b, I can move b to the front. So this is going to equal b times ln a. So over here, I have ln x to the power of x minus 2, and I can move x minus 2 to the front. So then x becomes a normal term, which makes it much easier for us to solve for the value of x. So if I move x minus 2 to the front, I get x minus 2 times ln x is equal to ln 1. Now, ln of 1 is equal to 0. So I get x minus 2 times ln x is equal to 0. And this gives me two equations. I have x minus 2 is equal to 0, and I have ln of x is equal to 0. So these are my two equations for this problem. Now, for x minus 2 equals 0, this is simple to solve. All I have to do is add 2 on both sides. So then these two cancel out, and I get x is equal to 2. So this is one solution of x. Now for ln x equals 0, well, ln, it's basically asking ln of what is equal to 0. And how we solve this is we can take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of 0. E to the power of 0 is equal to 1, so I get e to the power of ln x is equal to 1, and e and ln cancel out, so I get x is equal to 1. So now we have our two solutions, but we have to check if they're right, because several times we can get a solution and it won't work out in our equation. So going back, our equation was x to the power of x is equal to x to the power of 2. And our solutions were x is equal to 2 and x is equal to 1. So let's first start with x is equal to 2. If I plug in x equals 2, I get 2 to the power of 2 is equal to 2 to the power of 2's. So I plugged in 2's over here and 2 over here. 2 to the power of 2 is 4, and again 2 to the power of 2 is 4, so this is right. Now I'm going to plug in x equals 1 for this. So I get 1 to the power of 1 is equal to 1 to the power of 2, and 1 to the power of any number is 1, so I get 1 is equal to 1.